Welcome back. So from this lecture onwards, let's explore about pointers in C. Pointers are one of the most important and essential programming feature which is available in C programming language. Pointers make C programming language more powerful. Also, pointers are heavily used in embedded C programming in order to talk to the peripherals, read data from the peripheral, write data to the peripheral, to configure the peripheral, to store data in some RAM location. So everywhere we use pointers. So from this lecture onwards, let's study about pointers step by step. First of all, what is a pointer? So now let's explore that. Consider this a memory organization in a computer memory. So here, these are actually different memory locations of a computer memory, and each location can hold 1 byte of data, right? And here, so these are the addresses. And unique address is given to each and every memory location of the computer. So a memory location address is called as a pointer. So pointer is nothing but a memory location address. So this is called as a pointer. The reason for that is it actually points to the data, right, which is stored in the associated memory location. So this is the data, right? So this address points to the data. So this is called as a pointer. So by using this pointer, you can do various operations. So what are the operations possible? So you can write into this pointer, right? So that means you can write a new value into this memory location. You can read from this pointer. So that means this value can be read in the program by using this pointer. So you can increment this pointer and you can go to the next memory location, right? So, or you can decrement this pointer and you can go to the previous memory location. So all these operations can be done on this pointer. So hence a memory location address is called as a pointer. And on 64-bit machine, the size of this pointer is 8 bytes, that is 64-bit. So for example, if you consider 32-bit ARM microcontroller, the pointer size will be 4 bytes or 32-bit. If you consider PIC-18 microcontrollers, then a pointer size will be 2 bytes. So pointer is nothing but memory location address. And in the next lecture, let's see how to store a pointer inside the program. So in the previous lecture, we come to know that a memory location address is a pointer, right? For example, this one. Let's see how to store this pointer inside the program. Alright, so before that, how do you store a data or a value inside your program? Let's say I want to store the value of the temperature. So what I do, I actually create a variable for that, right? So I actually select a data type, let's say char, and after that I create a variable, let's say temp, and after that I initialize that variable. So let's say 17. So here, this is the data, and we stored that data inside our program by using a variable. So this variable will be used to manipulate this data, right? So I can compare the temperature, I can increase the temperature, decrease the temperature, I can print the temperature. So all I do by using this variable, right? The purpose of variable is to manipulate the data, right? So in the same way, if you want to manipulate a pointer, you have to create a pointer variable. So once you create the pointer variable, you can use that variable to manipulate this pointer. So you can carry out various operations. So what are the operations possible on this pointer? You can read from that pointer. You can write into that pointer. You can increment that pointer. So you can decrement that pointer. So these are various operations. So as I mentioned before, and all you can do that once you create the pointer variable. So now let's see how to create a pointer variable, and that we call as pointer variable definition. Same as your normal variable definition. Here also you have to first mention the pointer data type, and after that you have to give a appropriate name for the pointer variable. So now before that, let's explore what are the pointer data types that are available in C programming language. So these are the pointer data types which are available in C. So you have to use this asterisk in order to differentiate between a pointer variable definition and a normal variable definition. So instead of char, you have to use char star. Instead of int, you have to use int star. So like that. You can even use unsigned flavor of that. So now let's write a code in order to store a pointer inside the program. Let's say this is a pointer, and let's see how to store this pointer in the program. So this is a number, right? So from the compiler point of view or from your point of view, this is a number, right? Let's select a suitable data type for this. So this seems to be a very big number of 8 bytes. So we have to use long type, right? So what I do is I actually create a variable of type long int. Let's say some address, and then I initialize this variable with this number. So is this a pointer variable definition? No, it is not, because for you or for the compiler, this is just a number. This is not a pointer. And you have stored that number inside a variable of type long int. So there is nothing special about this statement, right? You may be thinking that this is a pointer, but for the compiler, it is absolutely not. For the compiler, it is just a number. So now how to tell the compiler that this is not a number, but this is a pointer? So unless you tell that to the compiler will not let you to treat that as a pointer, and it will not let you to do the pointer operations such as read, write, increment, decrement, and various other things. So now you have to tell the compiler that this is not just a number, but it is a pointer. It is a memory location address. For that, we have to use pointer variable definition. So what I do is, so I go to the next line. So now let me create a pointer variable. So first you have to select the data type, right? Pointer data type. So now let's randomly select one pointer data type. Let me select char star. This is a pointer data type. After that, let me create a variable. Let's say address 1. And after that, I initialize this variable to this number. So now again for the compiler, this is just a number, right? Of type long int, right? But the type of this variable is pointer type, right? So hence there is a data type mismatch, right? So tell the compiler this is not a number, but this is a pointer by using explicit casting. So let's cast this number to char star. So now compiler will consider this as a pointer, not as a normal value or data. This is a pointer. And you have stored a pointer inside the pointer variable. Now you can use this pointer variable to manipulate this pointer. So hence, this is not a valid pointer variable definition. So let me remove that. So this is a valid pointer variable definition and initialization. So remember that if I remove this explicit casting, then what happens is compiler will generate errors. So you can see that, or it can generate warnings, right? Sorry about that. So see here, there is a warning, right? Initialization of char star. Yes, initialization of a char star from long int. That means the compiler is considering this as a normal number. So tell the compiler that this is not normal number but a pointer by using pointer data type. So by casting with pointer data type, which you used at the left hand side. Welcome back to the lecture. So in the previous lecture, you just learned about pointer variable definition and initialization. And here we did something like this, right? So here, this is called as pointer variable of type char star. Let's understand more about this variable definition. So the moment compiler sees this definition, compiler allocates 8 bytes for this variable to store this pointer. All right, now let's move forward. So when the pointer variable is created, so let's say the pointer variable in our case is address 1. So when it is created, 8 bytes of memory will be reserved for this variable. Why? Because in 64-bit machine, a pointer size is of 8 bytes, right? So that's why irrespective of the pointer variable type, compiler will reserve 8 bytes of memory to store a pointer. And here you can see that the initialized pointer is actually stored inside the variable, right? So this is actually the address of this pointer variable. And this is a pointer stored. And that pointer is nothing but one of the memory location of the computer, right? And it may be having some value. So briefly, you can visualize something like this. So this is a created pointer variable and it is initialized to this pointer. And this is the address of this variable. And this may be pointing to some data in the computer memory, right? So you can visualize something like this. Let's move forward. So it doesn't matter which pointer data type you use for the pointer variable. The compiler will always reserve 8 bytes for the pointer variable irrespective of that pointer data type. So it doesn't matter whether you use char star, int star, or long int star, it doesn't matter. So compiler will always reserve 8 bytes in this case because our machine architecture is actually 64-bit. So in other words, the pointer data type does not control the memory size of the pointer variable. So then what is the purpose of mentioning the pointer data type? So then why do we have to mention this? So in normal variable definition, so when I write char, let's say temperature is equal to 30. So here compiler actually reserves 1 byte, right, for the temp variable, correct, in order to store this value. So, but that is not the case in pointer variable definition. So irrespective of the pointer data type, always 8 bytes will be reserved for the variable, right? So then what is the purpose of mentioning the pointer data type? Let's see why. The pointer data type decides the behavior of the operations carried out on the pointer variable. So the operations are read, write, increment, decrement, and so on. So basically, this pointer data type is used to control the behavior of the operations what you perform on this pointer variable. All right, so here are a couple of pointer variable definitions by using different pointer data types. So now let's consider this statement. So here a pointer variable is defined using char star pointer data type. So the meaning of this variable definition is when the read operation is performed on the address 1, then the read operation yields 1 byte of data out of this pointer. So this actually decides how many bytes of data can be read from this pointer when read operation is performed. Same thing applies to write operation, increment operation, decrement operation. So if you consider this definition, so when the read operation on this pointer variable is performed, the operation is going to yield 4 bytes of data out of this pointer. So the read operation on this variable, in this case, yields 8 bytes of data. So that's why in this case, this variable is also called as a pointer variable to char type data or pointer variable to 1 byte data. So in this case, this variable is also called as a pointer variable to int type data or 4 bytes data. And in this case, this variable is also called as a pointer variable to long int type data. So if you are confused, then when we do the programming or when we cover the examples, so it will get clear. But the takeaway from this slide is, so this actually decides the behavior of the operation, what you do on the pointer variable. So now let's understand how to read data from the pointer. So all you have to do is you have to dereference the pointer. So this is called dereferencing a pointer variable. So here you have to use star in front of the pointer variable name. So if you do this, value at this address will be fetched and it will be stored in this variable data. So in the pointer context, this symbol is also called as value at address operator. So the compiler will fetch 1 byte of data from this pointer and it will store that data into this variable. So why compiler will fetch 1 byte of data? Because its type is char star. So that's why only 1 byte will be fetched. So now let's move forward. Let's take an example. So this is a variable, a pointer variable, and it is initialized to this pointer. And this pointer that is currently having, let's say, this value that is 0 cross 85. So when you do this, this is actually nothing but you are dereferencing this pointer variable, right? So that means you are dereferencing this address. So that means dereferencing means fetching the value which is present at this pointer, which is 85. So 85 will be stored in this variable. That's what we call as dereferencing. Let's move forward. So write operation on the pointer. For example, if you want to write data into this pointer, so then all you need to do is you dereference that pointer and you replace the value with new value. So this is called dereferencing a pointer to write new data. So here we are actually writing new data into the memory location which is addressed by this pointer. So simple, isn't it? So for example, let's say this memory location currently has this value 0 cross 85 in the memory location. So once you do this, what happens is it is like you are replacing the content of that memory location, right? So it becomes like this. So you are replacing this value by a new value. All right. So now it becomes 0 cross 89. So that is what we call as write operation on the pointer. So all these operations you do by using the pointer variable. So instead of directly using the address here, you are using pointer variable. So with that note, I would like to end this video. Before ending this video, I would like to give you one exercise. So this exercise you have to do, and I'm going to solve this exercise in the next lecture. The exercise is you have to follow these steps to do certain things. First one is create a char type variable and initialize it to value 100. That is very simple to do, right? So you can do that. So after that, the second thing what you have to do is print the address of the above variable. So you can do this by using printf statement with a format specifier %p, right? And after that, create a pointer variable and store the address of the above variable. So for this, you have to use address operator, that is ampersand. After that, perform read operation on the pointer variable to fetch 1 byte of data from the pointer. Print the data obtained from the read operation on the pointer variable. Perform write operation on the pointer to store the value 65. Print the value of the variable defined in step 1. So I want you to do all these steps, and by doing these steps, so we'll learn a lot of things about how pointer behaves, and I will explain you this exercise in the next lecture. Welcome back to the lecture, and let's do this exercise. First thing is create a char type variable and initialize it to value 100. So now let's do that. So let me create a variable called data and initialize that to 100, a char type data. And after that, print the address of the above variable. So now let's print the address of this variable. For that, you have to use printf with %p, right? Of the variable data is %d. Correct? And you have to use address operator here, right? That is ampersand. That is address of this variable data. Right, so here let me also print the value of data. Value of data is %d/n. Let me also print data. Fair enough. So now let's compile and let's see how this goes. Let me run this code. So that seems to be some problem. So percentage p, sorry. So now let's run. So value of data is 100 and the address is this one. That's great. The next thing is create a pointer variable and store the address of the above variable. So now we have to create a pointer variable and store the address of this data variable. First, let's create a pointer variable. For that, we have to select a pointer data type. So now let me start with a very basic pointer data type, that is char star. Let me select char star as a pointer data type. So data type followed by the pointer variable name. Let's create a pointer variable. So while writing a pointer variable name, so always start with the letter P. So this is just a recommendation, all right? So this is not a compulsory thing that you have to do. So the lowercase p signifies that this variable is actually a pointer type variable. So it will help you to differentiate between different variables in a program. Let me give the name address is equal to. So now I have to store the address of this variable, right? So address of data. And after that, perform the read operation on the pointer variable to fetch 1 byte of data from the pointer. So now this is a pointer now, correct? So perform the read operation on the pointer to fetch 1 byte of data. So let me create a variable value is equal to, this is a read operation, right? So after that, print the data obtained from the read operation on the pointer. So we have to print this data now. Let's print that %d and let me print this. And now let me just compile this and let's see how this goes. And now let me just run this code. So value of data is 100. This is the address and here it is. The red value is 100. So what you did here was you actually dereferenced this address and you read 1 byte of data, right? So the value which is stored at this address is nothing but 100, right? So that's why the read operation also returned 100 here. And after that, next step is perform the write operation on the pointer to store the value 65. Let's do the write operation on the pointer variable to store the value 65. Let's store 65. And after that, print the value of the variable defined in step 1. So that means you have to print this variable value now. Let's do that. So value of data is data. So now let's see how this goes. And let me just run this code. And here it is. So here you can see that you actually changed the data which is stored in this variable by using pointer, right? So here you can see that first when we printed this variable, it was 100. Now it is modified to 65. That's because you actually dereferenced its address and you wrote a new value here. So you replaced 100 by 65 now by going through the address of that variable. Alright, so now let's summarize what we just did in this exercise. So first what we did was we actually defined a variable and we initialized the variable to value 100. So this is a variable name and this is the address of the variable and this is a value stored in the memory location addressed by this address. So that is 100, right? And after that, second thing what we did was we actually stored the address of this variable into a pointer variable called p_address. So that's why this variable is now holding the value, this one, which happens to be the address of the variable data. And after that, what we did was here, we actually dereferenced the pointer variable. So dereferencing a pointer variable is also means that dereferencing the address to read the value stored. So the value stored was 100. So that's why 100 will be stored in the variable value. After that, what we did was we actually dereferenced the pointer variable in order to write the data 65. So dereferencing a pointer variable is also means that we actually dereferenced the address, this one, to write the value 65. So 65 will be stored in the memory location addressed by the address, this one. So that's why in this memory location 100 is replaced by the value 65. So that's why when you printed the value of the data, it actually printed 65 instead of 100. All right, so also please keep this in mind. So here data is of type char, isn't it? So therefore ampersand data, that is address of data, this quantity will be of type char star by default. So if int temp is equal to 90, here temp is of type int, so therefore ampersand temp will be of type int star. So please remember this point. I hope you understood this exercise, and in the next lecture we'll discuss more about pointers, and I'll see you in the next lecture. Hey, welcome back to the lecture. So in this lecture, let's understand effect of using different pointer data types on pointer operations. We will discuss this by taking an example. So I'm in my IDE and let's write some code. First of all, our code now is going to have one global variable of type long int. Let me type long int, and the variable is, let's say, gdata, g underscore data. And I'm going to initialize this variable with 8 bytes long data. I'll write in hex, let's say FFFE, so that is 2 bytes, and ABCD 1111 and 22345. So this is 8 bytes long data, right? 2, 4, 6, 8. So now after that, I'm going to create a pointer variable of type char star. Char star, a pointer variable. I will give the name p address 1. So remember that some people also write this pointer variable definition like this. So they actually move this asterisk from here to here. So please note that both these syntaxes are correct. So these two definitions are identical. So in most of the books and in most of the time, you actually find this one rather this one. So that's why from this lecture onwards, I would like to use this syntax. There is nothing wrong in using previous pointer definition syntax. So that one and this one is completely identical. So, but I don't want to confuse you with books and other literatures. So that's why I'm going to stick with this convention. After that, I'm going to store the address of this variable. So let me do that. So now if you try to compile this, you will see a warning here, right? So here it is. So compiler is saying that there is a type mismatch. Why? Because this is of type long int. So this is of type long int star, right? But this is of type char star. So LHS and RHS types are not matching, right? So that's why there is a warning. So in order to suppress the warning, so what you can do is you can just typecast this pointer with char star. Let's do char star here. This is what we call as explicit casting. So now this is fine. So now this is fine, no problem. So now here, this is a pointer of type char star. And this is a pointer variable of type char star, and both are matching. So there is no warning. After that, what I'm going to do is I'm going to print the address and the value. So what I'm going to do is just observe this value at address. Let's print the address. Percentage %p is %d. So I'm going to print this pointer variable and the value which is stored at this pointer. So for that, I have to use star pointer variable. Let's see what will be the result. Let's run this code. So let me print in hex. Let's see how it goes. I'm printing in hex. So value at address. So this is the address of this variable, right? Is 45. So observe here. So when you dereferenced this pointer variable, it actually printed 1 byte of data, not 2, not 3, not 4, not 8. It just printed only 1 byte of data. That is because its type is char star. So it's supposed to fetch only 1 byte of data from that address. That's why only 1 byte is printed here. That is this one. The first byte is printed. Let's create another pointer variable, and I will call it as p address 2, and this time I'm going to use int star. And again, let's do the same thing. So here address 2 is equal to, let me change this to int star, and value at address. So let's change this to address 2, and this is also to address 2. So take a look here what happened. So now again, value at address, this one is, so you are dereferencing an int star pointer variable. So that's the reason this operation is now yielding 4 bytes. So that means if you want to read 4 bytes at a time from a memory location, then use int star. If you want to read only 1 byte from the memory location, then use char star. And if you want to read 8 bytes at a time from the memory location, then you use long int star. So now let's use long int star. So now let me again copy and paste here. So before that, I would like to make one change here. So here, let's use short. Let's see what happens. Short address 3. After that, we can try long int. So let me call it as address 3, address 3, address 3. And this is short star. Short means short int. And after that, again, I create one more block. Let me call it as 4. And this will be long int, and or long. You can just use long, both are same. And here let's print, so this, let's change this to long star. So now let's print. So here actually this will yield 8 bytes of data, right, from the memory location. So that's why I have to change this format specifier to support 8 bytes. So that is I64X. Let's try. Here it is. The first one printed only 1 byte, second one printed 4 bytes of data, and third one printed 2 bytes of data because it is short star, right? So take a look here. So all these values are getting fetched from this address, which happens to be the address of this variable. And when you do long int star, so here you can see that 8 bytes are fetched, right? So that's how changing this pointer data type affects the behavior of the operation what you carry out on the pointer variable. So all these are actually read operations, right? You are reading from the pointer. All right, so here observe one thing, that so even if you drop this explicit casting, the result will be same. But the thing is, compiler will issue a warning. So, but this warning, actually it is not dangerous, but that doesn't mean that you should ignore that. So you should resolve that warning. But so here compiler is just saying that there is a type mismatch, but there is no information loss here, right? Because see, the size of this entity is 8 bytes, right? And the memory reserved for this variable is also 8 bytes. So a 8 byte pointer is stored in 8 bytes of memory space. So that is perfectly fine. So there is no information loss. So, but it is always good to maintain same data types at the left-hand side as well as at the right-hand side. So that's why it is better to typecast explicitly, just to make sure that the data types of LHS and RHS are same. So with that note, I would like to end this video here. And in the next lecture, let's understand more about pointer arithmetic. Welcome back to the lecture. So in this lecture, let's understand effect of using different pointer data types on pointer operations. Let's start. So now let's understand this with an example. So here I have a project. The project name is pointer_2. And here I have a small code snippet. And here I have a global variable called gdata, and its type is long int. And this is initialized to this number. And here I have a pointer variable p address, and its type is char star. And then it is initialized to address of this variable. ampersand g underscore data, and I have typecasted this to char star. And after that, here I am printing the value of this pointer variable. I'm just printing the contents of this variable. So that is nothing but an address, right? So that's why I have used %p here. Let's see what is the output of this. Output you cannot guess because it is going to print the address of this variable, isn't it? Let's see what happens. So we actually got the output. So value of this variable is this one that is actually an address, right? So address of this variable. So now let's print the value. So let me print both address and value at address. So now let's run this code and let's see what happens. So now can you guess the output here? So now here we are dereferencing this variable, isn't it? So that means we are dereferencing this address, isn't it? So that means we are going to fetch 1 byte of data, or we are going to read 1 byte of data from this address, and we are going to print that. Let's verify. So that looks great. So now what we do is we are going to increment this pointer variable content by 1. So for that, what I'm going to do is this is equal to +1. I'm going to do +1. All right, so after that, I'm again going to execute these two statements. So now can you guess the output? So first we actually had the data, right? G data, a global variable, and its address is this one, right? And in that address, we have this data, right? So this is a data or value. So now first we initialized p address is equal to address of g data, correct? And after that, we dereferenced this. So that's why we fetched 1 byte of data from this address that happens to be 45, correct? And now we increased the pointer content by 1, right? The content of this p address is this address, right? 11, correct? And now if I dereference this pointer or this pointer variable, so I'm going to get this data, right? 0 cross 23. So if I increment p address by 5, so p address value will be this address, right? So if I dereference that, I will get this value, correct? Let's test this. I'm going to execute this. As expected, p address is incremented by 1. So 10 becomes 11 here. And the value at that address is fetched. That happens to be 23. All right, so now let me change this to +5. Let's see the output. So now here, as expected, the address is incremented by 5, right? So 1, 2, 3, 4, 5, right? So now that's why the address is 3015 now. And the value, 1 byte of data at that address is AB, right? So that's why AB is getting printed here. So now these FFs are just to indicate that that is actually a negative number. So now what we're going to do is let's change the data type of this pointer. So I'm going to change this to short stop, and let me change here as well. And I'm going to do +1 here. Let's see how all these outputs look like. And that's it. And now let me run this code. So here is the interesting thing. First, it actually printed this address. That's correct. And now it actually fetched 2 bytes of data. And that memory location then incremented by 2 when you did +1, right? So when it was char star, the address incremented by 1, but here it incremented by 2. So that's why you see 3012 here. And then it fetch the next 2 bytes, that is 1 1. So first 2 3 4 5 got fetched, and after that the address is incremented by 2. After that the next 2 bytes are fetched. So I hope this is clear to you. So that's how this pointer data type affects the pointer arithmetic. So this is what we call as pointer arithmetic, right? So you are doing some arithmetic operation on the pointer, right? So when the pointer variable is of type short star, doing +1 actually incremented the pointer value by 2. Alright, so now let me change this to int star. Let's see what happens. So I'm going to run this code now. So here is the output. First it printed the base address 4030, and when you dereferenced that pointer variable, it fetched 4 bytes of data from that memory location. So that's why it actually printed the first 4 bytes. And after that, so when you increment the pointer by 1, the value actually increments by 4 now. That's why it is now showing 3014, right? And from there, it again fetched another 4 bytes. That means, so all these bytes. So the pointer type is now int star. So first you initialize p address to this address. And when you do +1, so the address will be incremented by 4. That means size of an int. So +1, 2, 3, 4. So now this is the value of the p address. And from that, 4 bytes will be fetched when you dereference that pointer. So when the pointer is of type int star, the pointer moves with an offset of 4 bytes, right? That is size of an int. So that means +1, this is +1. So +2, +3, +4, like that. And when the pointer variable is of type long star, then the offset will be 8. So this is actually +1. This is +2. This is +3. So offset is actually 8 bytes. So hope this is clear to you. So now pointer arithmetic and pointers are highly used in embedded system programming. So pointers are very much important in embedded system programming because you can use pointers to store data into required SRAM locations. So pointers are heavily used for copying data from peripheral register to SRAM memory and vice versa. Because in microcontroller, we actually talk to the peripheral registers by using its address. So if you want to put some data into the peripheral, or if you want to configure the peripheral, so you have to use its address. So all these things we'll see when we do exercise on the embedded board. So but all these pointers concept and pointer arithmetics and the typecasting what we just saw in the previous lecture, so all will be used while doing exercises for the embedded board or while writing code for the microcontroller. Pointers are also heavily used to configure the peripheral registers because peripheral registers are memory mapped and each register will be given unique address in the MCU memory map. So about the memory map and all, so we'll see later. So just you have to know this, peripheral registers are actually part of the memory map of the microcontroller. A unique address will be given by the microcontroller vendor to configure all those peripherals. And we'll explore more on this later. And after that, pointers to ISRs are stored in a vector table to handle the interrupts, and pointers are also used to configure the memory mapped processor specific registers like interrupt configuration registers and all. So that means that pointers are very much important in embedded system programming. And as we make a progress, we'll explore more. And in the next lecture, I'm going to explain you one important topic, that is we are going to understand about the importance of a standard library header file called stdint.h.